Dear friends, we shall now get into the questions regarding triangles. What you need to remember during this lesson is the meaning of the word ratio. Ratio means a similar relationship. Let me begin with an example. 1 out of 2 is same as 2 out of 4. That also is equal to 3 out of 6 or 4 out of 8, 5 out of 10. When you look at all these numbers, you realize that these are exactly half. 50 upon 100 is suddenly same as 1 upon 2. Half, which means both are having the same relationship. That is the meaning of the word ratio. Similar relationship. Numbers are different, definitely, but the relationship is similar. On the other hand, take the next example. 1 out of 2 or 1 upon 2 is certainly not equal to 1 out of 3. You understand that immediately. Or it's not equal to 4 out of 5. Which means these are not in the same ratio. Whereas the first ones are in the same type of relationship. Half. This also is certainly half. This also is half. Not only half, it can be a number, but then similar relationship. And therefore, based on this, we have two theorems. Theorem 6.1 and 6.2. Both are based on the ratio of the sides of a triangle. The relationship between the two sides of a triangle which are divided, so we can say. Therefore, theorem 6.1. If a line is drawn parallel to one side of the triangle to intersect the other sides at distinct points, then the other two sides are divided in the same ratio. Look at this diagram. We have a triangle ABC and we have the line DE which is drawn parallel to BC. DE is parallel to BC. We are given that. And the conclusion is, according to the theorem, that therefore these two sides AD upon DB will be equal to AE upon DC. You see, they are not equal, but they are in the same ratio, same type of relationship. Therefore, AD is equal to AEEC. And therefore, what you must remember in this theorem are these words. If a line is drawn parallel to one side, then the other two sides are divided in the same ratio. Theorem 6.2 is the opposite, we say the reverse of 6.1. And therefore we have, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Theorem 6.1, if the line is parallel, then the sides are proportionate, in the same ratio divided. And opposite, if they are divided in the same ratio, then the line is parallel. So here we have the detail. We are given that the triangle MNO and these two sides MP divided by PN, MP upon PN is equal to MQ upon QO. We are given. And the conclusion, because they are equal, the lines PQ and NO are parallel. So 6.1 and 6.2 are very similar, only 6.2 is the opposite, the reverse of 6.1. And therefore, the questions in exercise 6.1, 6.2 are based on this, are based on either it will be given the line is parallel to one another, or you will be told the sides are divided in the same ratio. And therefore, when you just see this is what is given, immediately you know you can solve the problem by making use of theorem 6.1, theorem 6.2. Now we shall see the question, how the questions of exercise 6.2, because 6.1 is very easy, simple, and the answers are given in your book, but then we will now see the exercise of 6.2. Here we have Question number 1 of exercise 6.2. The question here, we have the two triangles, both are independent. Only we are asked, we are given the measurement. So here measurement centimeters, in measurement centimeters. In this one, here there is nothing. And therefore we are asked, what is the measurement here? That is in figure number 1. Similarly, in figure number 2, we are given the measurements and therefore we are asked, what is the measurement here? So how do we do it? We follow theorem number 6.1 because it is given that the lines are parallel. If the line is parallel, then the lines will be proportionate. So we say, since the line is parallel, the lines have to be in the same ratio. So we say AD upon DB is equal to AE upon EC. So give the values. The values we are given here, we are applying. The only one without value is EC. At this time, what do? We do a cross multiplication, which means multiplying opposite. And therefore, what happens? You have 5 here, EC comes up, EC into 5, 1.5 EC, and 3 into 1, 3. Next step, we must separate EC by itself. Therefore, what do? Divide 1 point, here divide 1.5 by 1.5, it will become 1. Therefore, right side also divide by 1.5. And the answer is equal to 2 centimeters. There is no mistake at all. Okay, we continue the same question and we are asked in the second figure. We are given the measurements and then we say, since the D is equal to BC, we have the same theorem we are applying and then we apply the numbers and when you read it, notice AD is alone. Here too, you do cross one. Since AD is here, you have to multiply it in this way. This is what remains here. So we get AD by itself. 1.8 multiplied by 7.2 and then 5.3, 5.4 remains here. We by 1.8 and 5.5, 18, 54 is 3 times and 3 times when you divide here we get 2.4. So the measurement is 2.4. Of course this is a little arithmetic, but the follow method theorem 6.1. Now we have question number 2 of exercise 6.2 and here is the question. We are given that the sides, we are given the measurement of the 3 situations. If the numbers are in this proportion, all the 4 sectors are in this proportion. One question, sub-question, second sub-question, and then we have a third sub-question. And what are we asked to find out? If the numbers are like this, if the measurements are like this, are these two parallel? Is EF parallel to QR? Okay, how do we solve the situation? We come to the first instance and then we say, if the lines are parallel, then the sides have to be in the ratio. So we say, this is the ratio, this, and then we apply the number. And finally we say, when you apply the number, we find 1 upon 3 upon 1. And then is not equal to 0.3 upon 0.2. They are not in the same ratio. Therefore, we say EF is not parallel to QR. So in the first set. Second set, once again, same method. PE, so ratio one side is equal to ratio the other side. And then we apply the value. The value is given here. The value is given here, we are applying the values. And then what do you notice? Here too, when you have fraction, dear friends, when you have a fraction, how to simplify it? Cross multiplication. 4 into 9, 36. 8 into 4.5, 36. Left is equal to right. Fractions, we have simplified. 36 is equal to 36. Therefore, the line EF is parallel to QR because both the sides are in the same ratio. We have now the third one, third set of values. Here also we apply the third set of values. Ratio of first side is equal to ratio of second side, and we apply the values. Simplify. See, this is half of this. So we have 1 upon 2. Now 18, 36, again 1 upon 2. So therefore, left side is equal to right side. Same proportion, same ratio. Therefore, we say in this case too, EF is parallel to QR. Suddenly, it's a little arithmetical calculation following the Theorem 6.1 of geometry that we have seen. We now look at question number 3 of exercise 6.2. You are familiar with the question, and look at the figure. The figure we have, in this figure, what is drawn? LM is parallel to CB and LN is parallel to CD. What we have to prove? We have to prove that AM upon AB is equal to AN upon AD. What we have to prove. Now let us proceed. In the triangle ABC, BC is parallel to ML, and therefore this AM upon AB is equal to AL upon AC. We have, that's the first proof. Second, in the triangle ABC, we have DC is parallel to NL. Therefore, AN upon AD is equal to AL upon AC. And that's the second proof. Now look at this. First and second, what do we have? You notice these two are common. ALAC, ALAC. If these two are common, then these two also must be equal, and that is what we say. Therefore, from 1 and 2, we conclude that AM upon AB is equal to AN upon AB, AD proved. So you go step by step and it's easy to prove. We are making use of Theorem 6.1. If the lines are parallel, then the sides are in the same ratio. We have now question number 4 of exercise 6.2. Please make sure that the diagram is well drawn. You draw first the triangle, then you put DE parallel to AC. Join A and D and draw DF parallel to AE. And what is to be proved? BF upon FE is equal to BE upon EC. How to go about it? First of all, in the triangle ABC, the whole triangle, these two are parallel. AC is parallel to DE, which means this side upon this side is equal to FE upon EC. We have this. According to Theorem 6.1, if the lines are parallel, the sides are in the correct ratio. In the second one, ABE, we have the second one. DF parallel to AE, and therefore we have BF upon FC is parallel to this number, second one. And therefore BD upon DA, that is again according to Theorem 6.1. So first conclusion, second conclusion. From both of these, if you watch here again, these two are common. Both are same. Therefore, these two also have to be equal. That is what we say. From conclusion 1, from 1 and 2, we conclude BE upon AC, BE upon AC is equal to BF upon FC, BF upon FC, exactly what we are expected to prove.
Just a word of advice to all of you. Mathematics should not be studied by heart, except the principles and in geometry, the theorems. Try to understand what is given in the question and what you are asked to prove. From what is given, you can know what theorem you have to make use of in order to prove what you are expected to prove. And therefore, I hope you try to understand, and that is why I have also tried to explain, try to make you understand as best as possible how we have done the questions. And in the next lesson, we will try to solve certain questions of exercise 6.3 and 6.4, beginning with the meaning of similarities of triangles. I wish you all the best. I hope you have liked this lesson. If so, kindly share it with as many as possible.